All right, thank you, Lori, and welcome everyone. I'll be going over our new Jumpstart offerings for Project Explorer and grading optimization in Civil 3D. So you might be asking yourself, what is a Jumpstart? Well, our Jumpstarts are so that users of some experience in Civil 3D can just jump right in and get a workflow for the new functionality that you would see in either grading optimization or in Project Explorer. So we're going to take some real world examples. We're going to run them through, and in a day, we are going to go through and try to give the user everything that they would need to know to get up and running and actually incorporate these new tools within their workflow to make them more efficient. I'll start off the top of the webcast by discussing Project Explorer, and then we will take the second half to discuss grading optimization. Project Explorer is a way, it's actually an extension for Civil 3D where you can look at all these AEC objects, or most of them, and you can both look at reports and tables as well as making changes to them directly within a nice tabular feature. And it really shines because not only does it centralize everything in one location, but especially if you have multiple screens, which most people do, it gives you a place that you can just kind of have a dashboard on one screen while you're using Civil 3D on another screen. So you might be asking yourself, how do I get Project Explorer or grading optimization? Well, for both, they're actually included in the AEC collection. So if you have AEC collection rights, you have the option to download and install both Project Explorer and grading optimization. You can go to the landing of manage.autodesk.com if you have a login, or if you're the administrator on your own computer, you can actually use the Autodesk desktop app, look through there and just make sure that you install under Civil 3D grading optimization as well as Project Explorer. I would also highly recommend installing any patches to both Civil 3D, Project Explorer, and grading optimization, because especially with grading optimization being such a new product, they're adding new functionality all the time. All those functions are included from time to time with the patches, as well as bug fixes that are kind of integral to the requirements. Now, as you can see here, I have a model in Civil 3D that has begun, but I haven't done much to it yet after bringing it in from InfraWorks. I pulled out some labels, but you can see it's a basic road model with a bridge. There's also some drainage elements in it. So I don't have the alignment yet. I don't have sections cut. I don't have a lot of things that I would really need to interact with the model. Except when I launch Project Explorer, which you can find on the Home tab. As soon as I launch Project Explorer, right here you can see on the Project Explorer tab, and I'll just maximize it. Again, this tool really shines if you have a second screen and you can maximize the entire tool. But I could look at things like what alignments I have up here in the actual model. So you can see a number of alignments, as well as when I click on an alignment, it gives me a profile automatically. I can compare that profile with other profiles. So I can mark out my existing, and I could click on, say, my proposed alignment, and you can quickly see right here what my proposed alignment is. So I didn't have to build this, I just selected it after it was imported, and now I have access to see all of these things, like calculated stations. I can see layout, so you can see the different pieces. And if you look in the graphical view, they're highlighted, as well as any PVIs that I have laid out in the model. If you look up here, the other objects that I can work with in Project Explorer are assemblies, corridors, point groups, surfaces, feature lines, parcels, pipe networks and pressure networks, sample line groups, as well as some blocks and object sets. All the other options are pretty self-explanatory, except object sets are unique to Project Explorer. Object sets are a way that I can can specific actions that I wish to repeat over and over again on AEC objects. So in this case, you can see I actually have a storm network report that I can run and place into a document. I can put it in any number of formats, an Excel format, Microsoft Word, you name it, as well as run it again within an AutoCAD and place it as a table. So I could set this all up to run all of these reports that I'm going to do from time to time, and during any design change or iteration, I could then regenerate the report or take the required actions again, and all of them will update. Now let's take a look at some of the things we can try to accomplish with Project Explorer, starting with alignments. If I click on an alignment, you can see it brings up a grid view automatically. Depending on which profile I select under the alignment, it's going to highlight it, as well as right now shade it if I have shading turned on. So I could compare this design profile that I've drawn against a existing ground profile. So I can look here, you can see existing ground. I can also look down at the bottom here, you'll see that there are calculated stations. So I've got a station and calculation along here, which I can change the interval of if I wish, and that will change the calculations. I can use this and then create a table if I want to of this later, and either place it within AutoCAD or place it in a PDF or an Excel file or something like that. There's also the entities that make up the profile, so I can see those, and as I click on them, you can see they highlight in the graphical view, as well as the PVIs. If I'm trying to find a certain entity in the AutoCAD window, I can use this functionality and click on what I want. Let's say this first symmetric parabolic section. I can right click and say zoom to it, and that will take me right to the section. If I can't visualize quite where that parabolic section begins and ends, there are actually shortcuts for that within Project Explorer. If I click on the entity and I hold Control, you can see here the first 2 points, or here the each end of the parabola. I could also hold Control and click on the entity, which will highlight them permanently. So I could actually move around, I can continue working, and I can come back to them at any time. I just have to click anywhere in here to hit Control again to make that go away. And there are several other keyboard shortcuts and tips and tricks that would be covered in the Jumpstart. The assembly section actually gives me access to the assemblies in a way that I can use to manipulate what the assemblies actually are. So if I were to look in here at, say, this 4-lane divided, and I zoomed in, I could see the pieces that make it up. So I could show all assemblies. Down here you can see where they're associated with which region. So you could zoom to the region. I can see right here where the stationings are, as well as all of the pieces that make up the object. So you can highlight them individually. You can check them for the left and right side. And I could make changes to them directly if I wish. So right here I could change my lane width by just double clicking on it, and then a dialog will pop up asking me what the value is. I could save it. You can see a number of anything that you would normally be able to change in a subassembly, you can change directly in here and then regenerate it by clicking on the corridor section. So if I take a look at section 2 here, I can see there's actually an unnecessary subassembly in here. Looks like there's median flush on both sides. I can take that, and if I right click on it, I can actually delete it directly from that assembly. Do it on both sides. And now you can see that my assembly has updated. From there, I can go over to the corridors tab, and I can actually rebuild the corridor directly from here. So I can rebuild the corridor just as I do in the prospector, and now everything is updated. Speaking of the corridor view, the grid at top shows you the cross-sectional geometry at each station. So I can pick a number of stations, as well as any reference to a surface that it is targeting. So you can see right here, I've got a couple surface targets right here, and this dashed line comes up because I have it comparing to the existing ground. If I turn that off, I won't see that. So it gives me just a way to look at sections quickly. I can make a lot of changes. It works, as you probably can see, it works a lot faster than the section editor. And it just gives me access to a lot of things, as well as the ability to drill in to sub-entities, everything that makes it up. I can see errors anywhere that they exist, so I can come through here and kind of validate all of my things in the corridor and reconcile them before I move on. The Services tab in Project Explorer acts as my landing to show me all of my surfaces, gives me the option to create surfaces on the fly, as well as acts as both visualization changes, interrogator for the triangles, and if I have volume surfaces, it also acts as a rolling sum for the volumes dashboard, all in one location. So as soon as I click on it, I have all of that information. I can also change styles of my surfaces. So you can see I have one surface displayed over here. If I wish, I can right-click on it and change the surface style to something else, and then it will update automatically. The surface triangles down here, if I wish, again, I could make those into a report, so I could have all of them. I don't have, in this case, I don't actually have parcels or feature lines for the interest of time, but I do have a couple different pipe networks. I want to locate where those are in space. I can zoom to them. And here's one end of my bridge has one unique network, and you can see the other end has another unique network. I can see from here, up in the graphical view, I actually have the option to look at specific pipe runs. So if I identify the pipes that I want to look at, I can just show them in profile quickly without even the need of creating individual profile views to edit them in profile. So let's say I want to go from manhole 30 to manhole 26. I can just change the upstream and downstream manholes, and then I can see that pipe run on the fly. Taking this pipe run and isolating it gives me the option to come down here and see the entire run. I can again change the interval on it, but I can make mass changes to it. So looking here, and I'm seeing kind of a series of different slopes. Let's just say I want to set the whole thing to a 2.5% slope by simply clicking Edit Pipe Run and then changing the slope over the entire run. Now, if you've been IMAGINiT customers for a while, you've already had this functionality in with the IMAGINiT tools, but this just gives it an interface in which you don't even need the profile plot to accomplish this. I can also reconcile errors that I might have inside of Project Explorer. If I look down at the bottom, I can see I have a number of inlets, and they're warning me right now that the rim does not match the reference surface. If I take a look, I do not have the auto surface adjustment set for those, which is probably why they did not fire. So I can grab the range of them, the ones that I want. I can right click on them and I can set that flag to true. So I'll say set auto surface to yes. And now when I go back and rerun the rules, if it hasn't already, so some of it did, you can see it automatically updated. But for any that I missed, I can go back, check it, make sure that they are have the settings, they're set to the right surface, rerun the rules, and then it should bring everything up all at once. If I want to select a bunch of objects and identify them inside of the regular AutoCAD window, I can grab a series of them just by using standard keyboard controls, control to jump around, shift to grab a range. Again, right click and say select them in AutoCAD. Now you can see if I come over here, all of those objects are selected. And if they're the same type of object, of course, I can change the properties of like objects if I want to as well. Lastly, in the Jumpstart, we will help you take full advantage of object sets. So again, these are actions that I can and repeat over and over again and do a multitude of things like creating tables and reports, things like that. I already have one set up to just create an AutoCAD table in model space. So I've placed it. I've made sure to set it to either manual or dynamic, so I can make the report static if I want to or not. And then the actions just need to be manually run by clicking on them. And then I can actually see when I come up here in model space that I have a table that I didn't have before. So this table, again, this can be generated internally or externally on a report. You can also go through and via the Project Explorer, you can set up which columns you want to show and which ones you want to suppress and which order that you want them. You can change the name of them. You can change the formatting of the table, things like that. All of that is something you can set up in Project Explorer, run it, generate it, and if any design changes occur, you can always run it again. Let's switch gears now and we'll talk about the grading optimization Jumpstart. So in this service, we're going to talk about grading optimization, how to use it, the layout, as well as some of the things that give you an idea of the best practice of how to use it. Grading optimization, again, like the Project Explorer, right now is something that's only available through the AEC collection, but it's something that has a separate installation. You should see it on the Analyze tab if you have grading optimization there, and then when you actually open it or run Optimize, it'll open up a separate window. So what grading optimization does is takes these areas and the line work that you were going to have to do at the beginning for a conceptual design or a master plan. Before you've even started any detailed design, you can use some of that line work, and we'll show you tips and tricks on how to quickly create closed areas that the grading optimization calls zones, and then those zones will then be overlaid on each other with a hierarchy. So when we place it in there, we're going to be able to actually do detailed grading just with a conceptual design. So if you've ever run into the situation, which I'm sure we all have, where you've done detailed grading and then all of a sudden somebody makes a significant change to the design, now that grading or a huge portion of it is now void. This allows me to just change the conceptual, add a new area, and then come up with an entirely new grading scenario on the fly in a matter of, well, depending on the size of it, you could run it for a couple minutes, could be a few hours if you really want to get down to fine detailed grading. But it is hands-off from the user. I don't have to work on the grading. I can go work on something else while it's running. But the first things we'll need is you need to have a surface in place, so you need something to grade to. We're going to define all of the areas again, which we can show you in the Jumpstart how to quickly make that out of things like a master plan or a conceptual. We'll lay out some lines and areas for drainage, which it's going to use, and then we're just going to run it, and based on the slopes that we've given the zones, the grading is going to take care of itself. So at the end, I should have a grading solution that should be about 90% of the way there. And it's going to also generate a bunch of feature lines that we're going to use, that we would normally use in grading. I can massage those to alter the grading in some way. I can then use traditional grading tools, and then I'd have a completed design. So let's take a look now in the software at a simple site. I have some basic line work set up, and I've already gone through and set up a lot of the criteria for grading optimization. But at minimum, this is basically what I need. Here's my surface, here's some line work. If I were to click on the line work, I'll notice that they are closed polylines. You could also use hatching if you wanted to. And a little window will pop up from grading optimization, giving me the object properties that have been assigned to that object. So I can see the name of the object. I can see any criteria in here. So in this case, I have a building pad, which I've set limits to for minimum and maximum flat pad slope, or excuse me, flat pad elevation, as well as some other elements like a curb, the width of the curb, the height, areas for the parking, and then other areas for green space, as well as a grading limit. So every project is always going to have a grading limit, and that's going to be the extent of the grading, and it's basically going to be a feature line that is draped over the existing surface. So this is the hard limit for any grading. I can also exempt areas within my grading from grading optimization criteria. There are specific zones for that. So if I had a road or something like that that I pulled from a corridor and I wanted to match against the side of it, even if it went through the middle of my site, I could still exempt it from grading optimization and then use it as a grading edge and grade out from it. But at minimum, I'll have a grading boundary. So I'll have a grading limit. And then inside of it, I will have overlapping boundaries, which will then be set up as a hierarchy. So the grading limit is the lowest priority. Then you could have an inner kind of grading limit, if you will, for a green space with different criteria. So you can see I have a lower minimum and maximum slopes. And then I have another section in here for a parking lot, which is, again, lower slopes. And I've just stacked these together in a hierarchy when I actually launch grading optimization. If I go to the Analyze tab and I look at the grading objects, there are two tabs right here. One shows me the existing elements that I've already assigned as a browser. So I could see, here's my building pad, which I could then select, and it would take me to it. Here are the distinct zones that I have. See, I have a sidewalk, ADA ramp, a couple drainage specific areas, my parking lot, etc. So all of these, I could find the elements that are defined in grading optimization. I could find them using this browser, and they're going to show up as soon as I assign criteria. To assign criteria, I have to look at the tool palette that is specific to grading optimization. So when you install grading optimization, you will see a new tool palette, and it will give you all of these options. Most of them are types of zones, so a building pad and a sidewalk path, standard zone. All of those need to be closed areas. The exceptions are curbs could be straight lines, or they could be closed. So it'll make an island, or it will make a straight curb. And then you could also have things like drain lines, which of course you'll need, and low points to actually change the grading and affect which way this surface pitches. So I've set up some of those. You can see right here. I have lines that come down here, so there'll be a catch basin right here to pick up flow, and anything this can't pick up, I've then drawn a line from here to here to flow to this point, and then based on the cross slope, the slope settings of the zone itself in which it's in, it'll pitch the entire surface toward it between 1 and 5%. Same with low points that I could place in that are just going to basically be cones of depression around the local area. that will do the same thing. So if I see elements in my drawing that I want to add criteria to, I just have to find the specific criteria and then assign them to an object that doesn't currently have any. So actually, if I click here and here on these two, what are supposed to be islands, you can see that there's no browser, there's no pop-up that shows me that they are part of grading optimization, like I would say with this one. So you can see this island is set up, but these ones are not. I've already predefined the curve, but just to check it, if I knew that I was going to have a 1/2 foot curb, I could default them right here, and I can change the height and the width of them, and whether or not I want them reversed. And then when I click on the command, where it asks me to assign the curb, I'll just click on both of these closed polylines, press enter, and now they have become curb objects. So now that I have my grading criteria set, I can launch the Optimize panel, or grading optimization proper, and select an existing grade surface to target against. It takes a second to load, and when it does, it should open up this brand new panel. It looks a bit like the object browser in Civil 3D. So I can grab it, I can turn it, and I can look at it and see that I have distinct coloration areas. All of those, the colorations that I see, are based on a coloration overlay right here. So it does not look like the same color, but green, and then in which order it is, you can see that the building is on top of the green. So the green and this bluish seems to make some sort of weird red color for some weird reason. Then I also have the parking area, and I can see the curb, and then my drainage elements, as well as my low points and things like that right here. If I expand the zones are going to be shown in hierarchy as to which one is the most important. So the most important are at the top. So of course there's going to be the grading limit, which is going to be the lowest priority. And then as it solves the grading limit, it comes in and solves the one that's lowest on the list in the zones. In this case, it is my green space area. My parking lot is just above green space because if there is a conflict between the two grading criteria, I wanted to use the grading criteria for the parking lot. This happens to be lower slopes. This is a tighter slope. Therefore, I want this to be higher in the order. And then there's also my ADA ramp. So it'll have to solve here for my parking lot before I can place a ramp. And then the elevation of the parking lot will also inform the sidewalk. So that was even higher in the order. So I will set all of those up. I can take a look at all of my elements and make sure that I'm not missing anything. If at any point I see that something's missing, I just close out grading optimization, go back to Civil 3D, add the elements that I want, and then relaunch it. I can also, while I'm in the tool, if there's something that I don't want to run, so let's say I want to see what this area would look like without the parking lot graded, I could turn the parking lot off right now, and then when I run grading optimization, it would not bother to grade the parking lot. It would just use this outer zone here as the criteria instead. So you could run through multiple scenarios while you're still in the panel without actually leaving it. So now it's time to optimize, and we'll check our results while it's running. First thing I'm going to do is I'm actually going to change the number of iterations that we do. The number of iterations, there's no hard limit on it. When we look at the results, we can see where convergence starts to happen. So you may, depending on the complexity of your site, see a very smooth site that has a very well-fit solution at 1,000 iterations. You could set this to 10,000 or 100,000, depending on the complexity. Of course, then the time that it takes to run might become exponential, and it would take considerably longer. But for my site, the simplicity of it, I usually get a pretty good indication of what a good result would be around 5,000 iterations. We can also set, if we have any zones that are going to go to a default slope, we could set them here and just have the zones apply the default slope. I'm also going to cut and balance the site to a net zero as best as I can to minimize earthwork. And I'm going to try to go for the smoothest surface that I can possible. So it's going to go through a bunch of iterations. It's going to do the cut fill. Then it's going to try to minimize earthwork while it's going through all of these different scenarios. And then it's at the end going to try to smooth it out to improve the look of the surface. So as long as everything is okay, I can just click Optimize. And after it triangulates, I can take a look at it while it alters my site. So I can zoom in. Maybe let's take a look at one of these curbs like this one. Sometimes it helps to change the visualization. So we'll talk during the Jumpstart about the different visualization options. I'm going to turn on the wireframe so it gives me the edges. And you can see that my curb is starting to come into focus. So as I go through this, I'm not just going to walk away and let it run. I'm going to check a few things and make sure that it's actually working the way it's supposed to. So I can see my curb is popping up on the outside. I can see my curb here is popping up. If I come back here, however, it looks like this curb is going the wrong way. So that tells me that curb needs to be reversed. Let's just check the other islands and make sure if anyone else, any of the others have the same issue. And yes, this one does as well. But that's not the end of the world. At this point, I just stop the optimization. And then I can just change the criteria right in here. So I'm going to reverse this curb. And I'm going to reverse this one. And click Optimize again. It starts over from scratch. And it just begins the optimization over again. Now when I zoom in, I should slowly see the curb start to come into focus on both sides. I can also see things like the contours of the topology, so you can see them change as the iterations change. I can see an aspect of slope to show me, in this case, what the percentage of instantaneous slope is as it's triangulating the site, or an aspect of which way the slope is running. So you can take a look here and see that. Or I could look at the lines, the hydro lines, and see that from these drainage lines that I placed in the direction in which they have been drawn is going to change the pitch of my slope. So you can see my slope is going to change here. It's going to come down. And anything adjacent to this line is then going to come to this line, flow this way, and then end up right here. Notice how the other lines outside of it also run to the nearest either line or point. So this is all going to be pitched this way because that is the nearest drain line. And then I have an interface right along here where things start to drain to these low points that I've placed in. So the software is going to figure out where those ridges are and which way the water should break. And it's going to assign those automatically. If I don't like the solution that I see, if anything about it at any point seems to be missing an element, I just stop the process. I go back to Civil 3D, I add a new component, and then I come back in here. I'll see the new element and run it again. To check the progress of the site overall, I have a few different views, like cut and fill view. So it can show me what my cut versus fill is, any violations I have as it triangulates it, and I can hover over it, any violated area, and I can see what the violation is. Typically, they're very close to the actual result, so you can see here I'm a little low on the minimum drainage slope. And in these triangles, you can see that one just went away. As it works on it, it's going to try to eliminate these altogether. But you may still have some that are an issue. But the site is, at the beginning, retriangulated into smaller and smaller triangles. So as it goes through, it's going to try to minimize all of those areas and issues. If I look at the convergence plot, I can see how the process is going and how my convergence is coming. So if I can get down here to say 1, I would have an excellent fit. I could also see right here the volume that it's going to work on. So it's slowly chipping away at that net volume so that it gets hopefully closer to balanced, or at least as close to mathematically balanced as possible, and still meet the grading criteria that I have. It's also going to work on the terrain smoothness. So as a trend, you should see all of these come down. You should see the smoothness come down, as well as the volume. Once you get down and you reach feasibility of around 1, you know that you've got an excellent fit for the criteria that you've given it. But it's still going to continue if you let it run. It's still going to work on smoothness and refining the site a little bit more, because just meeting the grading criteria is not necessarily optimizing it perfectly for cut and fill or smoothness. So I can let this run if I wish. I could look at different areas. I could zoom in to a specific object that I'm concerned about, say an island. Right click on it and zoom to. Take a look at it. I can take a look at my ramp by doing the same thing. And at this point, if I am satisfied with the results, I don't have to continue running the optimization. I can stop at any point and send the results to Civil 3D. A window will pop up and it'll ask me to give the surface a name, and it'll also give me the option to generate feature lines and Kogo points that it will put into that surface. The nice thing about this is I could create a new surface, set any style to it, and then I could set all of these feature lines and points to a new site. And then I could go back into grading optimization and I could run it again and again, and I could compare the surfaces against each other if I wish. So I could look at all of them as an overlay. But I have already set up a surface for this. So I'll just go to the prospector and I will turn on the surface that I want to see. And if we look at it in the object viewer, you can see it looks more like a distinct surface. So bringing it all together, in InfraWorks, I can take a site that looked like this and turn it into a site that looks like this. And with that, I would like to open up the floor for questions.